Hi everyone, I am Esma from Chemistry Department. This video will be about my PHYS102 lab project. My experiment's objective is observation of the relation between the capacitance and the area ratio of the electric material. The experiment aims to prove that when the electric material is inserted perpendicularly between plates with varying area ratio, then capacitor behaves as if two new capacitors were formed and they are connected in parallel. Let's continue with theory part. Capacitance of a partially filled capacitor with dielectric material is equal to sum of each of the capacitor parts. As you can see from this equation, the experiment setup consists of parallel capacitor plates, inserted material with dielectric constant kappa, wire cables and multimeter. Before starting to experiment, I adjusted parallel plates to same heights. I measured the dimensions of the parallel plates and thickness of the inserted material, which was equal to the distance between parallel plates. I inserted the electric material gradually, then capacitance results are recorded with varying area ratios. In order to minimize the measurement error, this process is carried out 3 times using 5 different areas filled with the electric material. This table shows the capacitance measurement values with respect to changing areas of inserted dielectric material. Average of total capacitance measurements is calculated by using the data in table 2. In the graphical interpretation section, the equation in the theory section is simplified and then this equation is acquired. The linear correlation between varying distance h, thus varying area ratio, and total capacitance measurements are also seen in this graphs, best fit line and the equation. These are calculated results of total capacitances according to theory. As a result of the measured and the theoretical data comparison, average of the percentage errors is obtained as approximately 370% from the table given. Measured capacitances differed significantly from theoretical predictions due to potential error sources. For example, I used a basic ruler for measurements which isn't very precise. Also, I treated experiment medium as vacuum instead of air, adjusting the plates manually. Calibration issues of multimeter, rounding of values, and environmental factors like electronic devices in the lab also affect experiment results. In conclusion, the experiment confirmed that the total capacitance of a capacitor varies with the area of the dielectric material, acting like two parallel capacitors. Even though error was too big, I identified several potential error sources, including instrument limitations, human errors, and calibration issues. Additionally, the results showed a linear correlation between the changing area ratio of the dielectric material and the total capacitance.